Since the beginning of this session, I've been regularly referring to member attributes and member functions of my class. If I intentionally insist on this member term, it's just because there are non-member attributes and functions in my class. On the net, you will often see these referred to as instance variables and functions for member attributes and functions, and class variables and functions for non-member attributes and functions. Use the vocabulary you like. I personally say member and non-member. As long as we understand each other, it's all that matters. Together we saw that a member function or attribute was something present in the instance of our class. It means that the class needs to be instantiated for us to use this attribute and this function. Another property of member attributes is that each attribute will be different in every instance. We all agree that if two instances of the same class and an integer member attribute, if I change the attribute on one side, it won't be changed on the other, otherwise it would be a mess. But we can imagine that these behaviors could be what we want to have in our code. Variables and functions existing at the class level and not at the instance level. That's why we'll talk about class variables and functions, not at the instance level. I'd call these non-member attributes and non-member functions. To be able to specify this behavior in C++, we'll have to bring back an old friend of yours. In C, the static keyword. Remember this keyword that would allow you to allocate a variable in a particular location in your runnable where you could get the value by calling functions, have it locally in the compilation unit, etc. In C++, in the context I will introduce now, static has a new semantic. Let's figure it out together. We still have our old sample class with a sample constructor and destructor. Of course, we won't create instances here. It won't be useful. We'll see that in a moment in the main brackets. Here, I will declare a non-member function, and here I will declare a non-member attribute. You can see that both declarations are preceded by the static keyword. In the example, I decided to use here. Let's assume that we want a counter allowing to know at any given moment how many instances of the class have been made. We all agree that it doesn't make any sense to have this number of created instances inside a specific instance. This information makes sense only at the class level, not at the instance level. The class wants to know how many instances have been made. So for that, I will use a non-member integer, declared here as static, which I will name _nb_inst. Given the fact that this non-member, this static integer, is private, I won't be able to access it from outside my class. It means that I may access it from a function inside my class instead, whether it's a member or non-member. In my example in particular, I chose a non-member function to illustrate this notion and to use it in my example in a relevant way. Now let's find out how to use this. Declaring a function implies implementing it. We have our getNbInst bracket non-member function declared here. And we can notice at first sight that there's no difference with the member function. Actually, there is one. And a big one, but it's invisible here. Remember I told you earlier that C++ was lying to you, and that it would systematically pass as a first parameter an instance of your class in your back. So you can use your this pointer. In this case, of a non-member function, this parameter isn't passed to this non-member function. Therefore, it actually has 0 parameter, and you won't be able to use the this pointer in a non-member function. As you can see here, in this code, we don't have any reference to the this pointer. However, what I want is my _nbInst non-member attribute to return this value to my user. As my non-member function was declared as public and therefore accessible from the outside, the syntax to refer to a non-member of a class. class attribute, or function, use vocabulary you want. In just the name of the class, : the symbol we are interested in. It will work exactly the same way whether it's an attribute or a function. I think that we'll eventually have something very logical. When we're referring to a class attribute or function, we'll use this from the inside and the instance from the outside. And when we're dealing with a non-member attribute or function, we'll directly use the name of the class and the : the scope operator, as we used to with namespaces, and it's not just a coincidence. There's a little particularity. If my _MB_inst attribute is a non-member, I won't initialize it in a constructor. What I want is when my code starts running, when I don't have instances of my class to use yet, I want this non-member attribute to have a value. I don't want it to be in an undefined state. For that, we'll add in the class definition, in the .cpp, a line following us to initialize the non-member attribute. So here we can see that I have a static _MB_inst integer, therefore non-member. And in my .cpp, I will have the definition. Here we have the actual integer initialization, sample : $_MB_inst equals 0. Now it can be tricky because you might think that we're using it from outside the class because it's private. No, it's the only way to initialize a non-member attribute, a static attribute. So remember this syntax. We often tend to forget it. It's available everywhere on the internet anyway in case you need it. So here I'm initializing my static attribute, my non-member attribute. And using the static function, this non-member function, I'll be able to return the value. Now let's check out the main brackets. The main bracket is a little bit complicated because I want to highlight the fact that we have a number of instances that will increase and decrease through time. For that, I will start my main bracket and initialize a call to my getNBInst bracket non-member function to know the number of instances at t = 0. There probably won't be any. Then I'm calling an f1 function, and I'm calling again this number of instances to find out how many there will be at the end of my program. This f1 function defined above will create an instance of my sample class. This instance will be useless. It's just that I don't know if you saw it in the constructor where I increment _NBInst. Let me show you because I forgot to say it. You probably thought so. Here it is. When I instantiate, I'm incrementing my _NBInst. Okay? So here I have my instantiation. Therefore, I should have the _NBInst attribute incremented to 1. So at this state, I've got an instance. I'm then calling an FO bracket function defined above, which will also create an instance and output the number of instances. This will allow me to use the stack to simulate the fact that I have instances being created and destroyed because we haven't learned yet how to make dynamic allocations. Let's compile this simple little code. Let's run it. We can see that t = 0. We don't have any instance. I get into the code of f1 bracket, which will create an instance of my class. So by calling again the non-member function, I get an instance. It makes sense. I get into the code of f0 bracket, a second instance is created. I'm calling again the non-member function to know the number of instances. I have 2 of them. I'm exiting f0 brackets, so I have an instance destroyed when we expect the number of instances to decrease by 1. It now equals 1. I'm exiting the f1 bracket, same principle. The instance is destroyed when we're out of the scope of the function, so we will witness a decrease of the number of instances. And I get back to my main bracket, which will output the number of instances after the call to f1 bracket, and we do have 0. So everything works smoothly. There you go. Here you have a little example, not so relevant, but still interesting of the usage of attributes and non-member functions. It's not something you need every day. These are quite specific usages, but sometimes it might be relevant, and now you know how to do it. I'll see you in a moment for the last video of this day.